Beneath the rolling waves of the Pacific Ocean lies a place unlike any other on Earth. A world so deep, so remote, that it might as well be another planet. Picture this: an endless stretch of blue ocean, glittering carved into the Earth's crust. The Mariana Trench. At its deepest point, Challenger Deep, the seafloor plunges nearly 11 kilometers down. To put that in perspective, if Mount Everest were dropped into this abyss, its peak would still be buried under 2 kilometers of water. This is the deepest place on Earth, a realm where sunlight has never reached, where pressure is beyond human imagination, more than 1,000 times greater than what we feel at sea level. At those depths, every square inch of surface is crushed under a weight equal to several jumbo jets stacked on top of each other. Metal bends, steel buckles, and survival? It should be impossible. In this eternal night, the temperature hovers near freezing. Currents swirl in silence. The environment feels utterly hostile. For centuries, humans could only wonder, was it nothing more than a lifeless pit? A graveyard of sinking debris? Or could life, against all odds, adapt and thrive? At these depths, bones and shells could dissolve. Proteins, the machinery of life, should collapse. By every rule of biology, life should not exist here. And yet, reality has a way of defying expectations. The Mariana Trench is not just a hole in the ocean floor. It is a scar, forged by tectonic forces as Earth's crust collides and sinks. A place alive with violent energy, shaped by earthquakes and volcanic fire. But what makes the trench truly compelling is a possibility of life. Life that has found a way to endure crushing darkness, absence of sunlight, and near starvation. If creatures can adapt here, what does that say about life's ability to survive elsewhere? On frozen moons? Or oceans buried beneath alien worlds? And that is the mystery. What secrets hide in the deepest place on Earth? Is it a sterile wasteland? Or a cradle of strange and resilient life? Over this journey, we'll descend into the trench. We'll uncover this place on Earth is more astonishing, more unsettling, and more awe-inspiring than anyone ever imagined. Early human curiosity and history. In the early 19th century, long before sonar or submarines, humans first tried to measure the ocean's depth. The method? Simple. Weighted rubber reaching the bottom. The mystery unsettled explorers. What could possibly lie hidden in water so unfathomable? For seafarers, these unknown depths sparked more than curiosity. They fueled myths. Tales of monstrous creatures lurking below. Beasts so large they could swallow ships whole. Others spoke of a bottomless void, a watery pit dragging vessels to their doom. To sailors, already battling storms and isolation, the trench became a symbol of both terror and wonder. As science advanced, naturalists began asking sharper questions. Was the ocean floor a barren wasteland, crushed by pressure? Or could hidden ecosystems exist in the places humans could not yet reach? The debate raged for decades. Skeptics said life was impossible in such extremes. Others believed nature might still find a way. But without direct exploration, the trench remained an unsolved mystery. That all changed in 1960, when the world's attention turned to a strange-looking vessel, the bathyscaphe Trieste. Built in Switzerland, later acquired by the US Navy, Trieste was unlike any submarine before it. A massive gasoline float kept it buoyant, and beneath it, a steel pressure sphere, thick enough to carry 2 explorers into the abyss. Even so, no one knew if it would survive the crushing forces of Challenger Deep. On January 23, 1960, Jacques Piccard and Don Walsh climbed inside. Their descent began. For nearly 5 hours, Trieste sank through the Pacific, past the twilight zone, into the midnight depths, and finally, into the Hadal realm, where no sunlight has ever touched. Outside the tiny windows, nothing but blackness. The pressure increased with every passing meter, strong enough to crush most known materials. And then, nearly 11 kilometers down, they touched the seafloor. For the first time in history, 2 humans sat in the deepest place on Earth. And what they saw shocked the world. Life. Shrimp-like creature stirred in the silt. Something resembling a flat fish flickered in the darkness. Against all expectations, the trench was alive. But their triumph was fragile. The thick windows of Trieste began to crack under the stress. They could stay only 20 minutes before beginning the long ascent. With no cameras and only fleeting glimpses, their observations were incomplete. They had reached the bottom, but left with more questions than answers. After Trieste, the trench fell silent once again. For decades, no one returned. Technology and funding simply weren't ready. The abyss waited patiently, its secrets undisturbed, until half a century later, when new machines would finally descend. Humanity finally returned to the Mariana Trench, this time with technology far beyond anything the pioneers of 1960 could have imagined. Fragile steel spheres and weighted ropes gave way to a new generation of machines. Remotely operated vehicles, or ROVs, could plunge into the abyss while scientists remained safely on the surface. Autonomous underwater vehicles, or AUVs, navigated pre-programmed routes through crushing darkness, relaying back data on pressure, temperature, and glimpses of life that had never before been seen. The engineering was staggering. Titanium hulls replaced steel, lighter yet stronger. Pressure-resistant cameras could now withstand the darkness, their lights cutting through the void to reveal a hidden world. Even the cables connecting submersibles to ships were engineered to endure forces that would snap ordinary materials in an instant. At these depths, nothing could be left to chance. Every detail of propulsion, lighting, and life support had to be precise. Because one mistake 11 kilometers down would mean certain disaster. Among these explorers, one name stands out: James Cameron. In 2012, the filmmaker and adventurer made a solo dive into Challenger Deep aboard the Deep Sea Challenger, a vertical submersible designed for agility on the sea floor. Its pressure sphere, built from advanced syntactic foam and carbon fiber, protected him from forces strong enough to crush a nuclear submarine. For more than 3 hours, Cameron descended into the abyss, capturing high-definition footage and collecting samples untouched for millions of years. It was more than a personal triumph. His dive proved that with modern engineering, the trench was no longer a one-time conquest, but a frontier open for science. Suddenly, repeated exploration was possible. Biology, geology, and chemistry could all be studied in their most extreme form. Then came the 5 Deeps expedition, led by explorer Victor Vescovo. His mission: to reach the deepest points of all 5 oceans. Using advanced submersibles, Vescovo made multiple descents into the Mariana Trench. Each dive confirmed not only that life thrived in the blackness, but also that the seafloor was alive with hydrothermal vents, microbial mats, and strange organisms beyond imagination. Yet the dangers remain immense. At Challenger Deep, the pressure is over 1,000 times greater than at the surface. Temperatures hover just above freezing. Communication with the surface is limited, fragile, and delayed. One small error can mean implosion in an instant. For this reason, explorers often compare the trench to space. Both are hostile, both require extraordinary engineering, and both remain largely unknown. But unlike space, the deep ocean is alive. Its black waters conceal entire ecosystems shaped by chemistry rather than sunlight. In this sense, the trench is Earth's inner space, every bit as alien as the worlds beyond our planet. From Trieste steel sphere to titanium-hulled subs and robotic explorers, each new mission pushes deeper into this hidden frontier. The Mariana Trench is no longer a shadow on a map, but a living laboratory, proof of human ingenuity, resilience, and our relentless drive to uncover the unknown. The science of the depths. To understand the Mariana Trench, we must imagine a world utterly alien, yet connected to our own planet. At the ocean surface, the air's pressure is gentle and unnoticed, but with every meter of descent, that invisible force builds. By the time a submersible reaches Challenger Deep, every square inch of its hull is under more than 1,000 times the pressure we feel on land. Imagine 50 jumbo jets pressing down on a single square inch of metal. One flaw, one crack, and the result would be instant destruction. Pressure is only part of the story. At these depths, darkness is absolute. Sunlight fades just a few hundred meters below the surface, leaving the abyss in eternal night. Temperatures hover just above freezing, and food is scarce. Life here must survive without sunlight, relying instead on chemical energy. It is an environment hostile in ways almost impossible to imagine. But the trench is not just a biological challenge, it is a geological marvel. Formed by subduction, the Pacific Plate dives beneath the Philippine Plate, dragging oceanic crust into the mantle. This collision carved a rift nearly 11 kilometers deep, the lowest point of Earth's crust. Over millions of years, these tectonic forces have reshaped the ocean floor, generating earthquakes, landslides, and volcanic activity. The trench is part of Earth's engine. Its movements recycle crust, release minerals, and influence everything from volcanic eruptions to ocean currents that help regulate climate. Studying the trench helps us understand the delicate cycles that govern life across the entire planet. Hydrothermal vents within this system offer something extraordinary. Ecosystems powered not by sunlight, but by chemosynthesis. Here, microbes convert chemicals into energy, creating a food chain in one of Earth's harshest environments. Entire communities thrive on volcanic gases and minerals, proving that life can exist in ways we never thought possible. Sediments at the trench's bottom tell another story. Layer by layer, they preserve a record of climate shifts, ocean chemistry, and the history of continents. In this way, the trench is an archive, storing the memory of Earth's past across millions of years. But the greatest lesson may be perspective. The forces that shape the trench operate over spans of time so vast they make human history seem like a flicker. The pressure and cold remind us of life's fragility. Yet the organisms here also remind us of resilience, proof that life can adapt to even the most hostile conditions. Studying the Mariana Trench is not a curiosity, it is a necessity. It helps us understand Earth as a living system, its climate, its geology, and its capacity to support life. In the darkness of Challenger Deep, we glimpse not emptiness, but the invisible mechanisms that sustain our world. The trench is both scar and sanctuary, a reminder of Earth's silence and a monument to life's persistence. Discoveries of life and strange adaptations. When explorers first peered into the inky blackness of the Mariana Trench, they expected emptiness, a barren landscape of mud, rock, and unimaginable pressure. But what they found was astonishing. A hidden world, teeming with life. Strange, alien, and incredibly resilient. It was a revelation. Life could not only survive here, it could flourish in conditions once thought impossible. Among the first creatures to capture attention were amphipods, tiny shrimp-like crustaceans, delicate and translucent, drifting through the abyss. yet able to withstand pressures that would crush most organisms. In some areas, these amphipods grew to extraordinary sizes, a phenomenon known as deep-sea gigantism. Unlike their shallow water relatives, they had evolved to conserve energy, resist pressure, and navigate the dark, deriving energy from chemical reactions instead. Some fed on minerals seeping from the earth itself, converting toxins into nutrients. An ecosystem entirely independent of photosynthesis. These microbes formed the foundation of trench life, feeding amphipods, snailfish, and countless invertebrates, and hinting at something even greater, that life could exist beyond Earth, on icy moons or distant planets. Hydrothermal vents and cold seeps added yet another layer. Mineral-rich fluids poured into the water. Microbial mats blanketed rocks. Clams, tube worms, and tiny crustaceans gathered around these chemical oases. Here, life wasn't powered by sunlight, but by pure chemistry. In this eternal night, some creatures evolved light of their own. Bioluminescence. Tiny flashes danced across amphipods. Other organisms glowed to lure prey, confuse predators, or send signals in the dark. In this black void, light itself became a language. These discoveries reshape our understanding of evolution. They show resilience in its purest form. Life finding a way when all odds are stacked against it. The trench becomes a living laboratory, teaching us about adaptation, balance, and survival. And they expand our imagination. If life thrives here, in conditions harsher than the surface of Mars, then perhaps beneath the ice of Europa or Enceladus, other worlds are waiting. But even with all the science, there is something more. An emotional impact. Watching amphipods drift like glass phantoms. Snailfish gliding in near silence. Microbial mats glowing faintly, untouched by sunlight. It evokes awe and humility. A reminder that on our own planet, mysteries remain more alien than distant stars. The Mariana Trench teaches us this: life is resilient, life is inventive, and life is endlessly surprising. Shocking human footprint. Even in the remote abyss of the Mariana Trench, where sunlight has not touched for millions of years, humanity has left its mark. In 2019, explorers made a shocking discovery, settling in the most unreachable places. The fact that it reached the deepest point on Earth forces a difficult truth. Humanity's footprint is everywhere. The deep ocean, a world of alien beauty and ancient resilience, is now vulnerable. Organisms that endured nature's harshest conditions for millions of years are facing a new challenge, born not of nature, but of us. The amphipods, the snailfish, the micromats, all touched by pollutants far beyond what their ecosystems can process. It is a heavy influence has spread. Amid the wonder and the discoveries, we're left with the sobering truth. Even the most extreme, most remote corners of Earth are fragile, and it is our duty to protect them. As we rise from the depths of the Mariana Trench, a paradox comes into focus. Here lies a world of alien beauty, sculpted by millions of years of geological forces, inhabited by creatures that seem almost otherworldly. And yet, even here, in this most remote environment, humanity has left its mark. Fragments of plastic drifting among amphipods, microplastics embedded in organisms that once thrived in complete isolation. The deepest reaches of our planet, once thought eternal and untouched, because these depths dwarf our technology and imagination. And awe because life persists here against odds that defy comprehension, adapting in ways that inspire both wonder and curiosity. The Mariana Trench reminds us that despite all we have achieved, our journey of understanding has only just begun. We have glimpsed around that few will ever see firsthand, yet its lessons belong to everyone. The ocean calls us to explore with care, to marvel with respect, and to recognize that even in the most extreme corners of Earth, there is still so much more left to discover. We have only just begun to understand our planet, and the Mariana Trench stands as a testament to the extraordinary mysteries that await those who dare to look deeper.